Okay, good morning. Assalamu alaikum. Welcome back, guys, to grade 11 mathematics by Inspired Teens. In today's lesson, we'll be continuing with can you guys hear me? Could you guys hear me this whole time? But we'll be continuing with trigonometry. Okay, please do confirm that you guys can hear me and that you guys can see me and that you guys can see my screen. And that's number 3 and 4 and 5, and that the screen is not blur. Is the screen blurry? Is it clear or is it blurry? Yeah. Okay, great. And you guys can see me and hear me and everything's working fine. Okay, perfect. That's good. Right. Let's continue. Okay, so last time where we ended, okay, we did some of these questions, right? If we just revise quickly from the start. Okay, we started off doing the basics of trigonometry, okay, learning about sine, cos, tan, revising Pythagoras theorem, adjacent, opposite, hypotenuse, and all of that, okay, basic wait, sorry, I forgot to share the YouTube link. Let me just do that quickly. Okay. So, yes, we did basic cast diagram. We discussed Cartesian plane questions, okay? And yeah, so just give me 1 second. Right, we did Cartesian plane question, basic cast diagram, and so on. Then we did reduction. Okay, we did all the examples of reduction. Let's just revise. We did 90 and 270 restriction, negative angles, angles larger than 360, and squared trig ratios as well. We also discussed co-functions. Okay, let's move on. Then we did some reduction questions from past papers. Okay, so just like, because they inculcate reduction with everything. 2 examples. We spoke about reciprocals, which are important to understand. We spoke about special angles. Okay. We spoke about solving things without calculators. Okay. We spoke about Cartesian plane questions. So Pythagoras questions, utilizing a Cartesian plane, to solve for these questions, right? They give you like 3 sine theta and minus 2 is equal to 0. Then they give you another criteria like tangent theta is less than 0, and you have to solve accordingly, right? Okay, then we did another question. Okay, this is an important question that we went through because it was a little bit different. Okay, here we have to combine 2 different triangles and have the understanding of reduction within a Cartesian plane. Okay, we did some in terms of questions. Okay, calculate this in terms of k, in terms of p, whatever, without the use of a calculator. And there's this example, which I believe I gave the memo for, and I wanted you guys to try it out. But let us continue, right? We said that today we're going to continue with trigonometric identities, which we actually did start and we went through them, but we'll revise them one more time. We go through them properly and then have a look at some of the questions, right? Yes, indeed. Let's just do this. Okay, cool. So, trigonometric identities, we can start off with the very first one, which is cos squared x plus sine squared x is equal to 1. From that, we can deduce if we rearrange the equation, okay? Like, for example, if I take sine x over to the other side, I can rewrite it as cos squared x is equal to 1 minus sine squared x. Similarly, if I take cos squared x over to the other side, I can get sine squared x is equal to 1 minus cos squared x. So these are important for you to understand, memorize, you need to know them like how you know your name. That's okay, it's as important. Okay, then we can discuss the tangent rules. Okay, so tangent rules, tan x is equal to sine x over cos x. Okay, and then we have tan squared x is equal to sine squared x over cos squared x. Okay, thereafter, what do we have? We have 1 over tan squared x. Okay, so 1 over tan squared x, this is like the reciprocal of it. 1 over something just basically means you flip it. Okay, and you get cos squared x over sine squared x. Okay, and then for 1 over tan x, same thing. Instead of having sine x over cos x, you have cos x over sine x. It's flipped. Let's have a look at negative angles, which, like I said, we've discussed before. And sine negative x is equal to negative sine x. Okay, as well as tangent negative x. Tangent negative x is equal to negative x as well. Is equal to negative tan x. However, okay, cos negative x, that is not equal to negative cos x. This is equal to positive cos x. We said that cos x swallows that negative. Okay, let's have a look at this. These are also important. So these are a bit more tricky, a bit more advanced, but we can go through them nevertheless, right? We can have the structure of it so that we can try to understand it in questions. Trigonometric trinomial identities. Okay, C is equal to a constant, example 2. So in all of these examples, C is our constant. We can have a trigonometric trinomial identity example, such as the first one, which is sine squared x plus sine x. So we have a squared sine term, a regular sine term, and a constant. So sine squared x plus sine x plus constant. Alternatively, that could just be replaced by cos, where we have a cos squared x plus a regular cos x term plus a constant. All right, that's the second one. And finally, the third one, okay, the third one is when we have sine squared x, okay, and at the end, you'll see we also have a cos squared x. So we have a sine squared x, we have a cos squared x. In the middle, we have the combination of both, sine x times cos x. Okay, so let's look at how can we solve an example. I think I told you we'll do this next week, and I told you maybe some of you should try it. Okay, so let's go through it today, right? If you tried it, you can mark it. Alternatively, you can listen to it for the first time. So we have 2 sine squared x minus 5 sine x plus 2. So there's 2 ways of doing this, right? The first way is just approaching it like how you approach regular trinomials and keeping sine x as your variable. Okay, because remember, this is essentially like having x for sine x and x squared for sine x squared. So how you sorry. So just like how you'd factorize 2x squared plus 5x plus 2 is the same way you're going to factorize 2 sine squared x minus 5 sine x plus 2 is equal to 0. So you're going to open up your 2 brackets, make them a bit big because we're going to have trigonometric terms inside. Okay. Now we can consider the factors of the first term, and that's going to give us our first terms in the brackets. Okay. The first term is 2 sine squared x. 2 sine squared x, okay, and the only factors or the factors of 2 sine squared x are 2 sine x and sine x. 2 sine x and sine x, because we need to get sine squared x, and then the coefficient is 1 and 2, so 2 times 1 and sine x times sine x, that's 2 sine squared x. Sines, remember, if the second sign is positive, both take the first, so both should be negative. Then we look at the factors of the last term, which are 2. That's going to give us our last terms in each bracket. And yes, the only factors of 2 are 2 and 1. But where do I put the 2 and where do I put the 1? Because if I put the 2 there and I do outer inner, I'm going to get negative 2 sine x, negative 2 sine x. All right. So that's how we know it's incorrect. What's incorrect about it? We need to flip it. 2 needs to go there, the 1 needs to go there. Sorry. Okay, so yes, then we have outer inner. Jeez. Okay, and when we do outer inner, right, what is outer inner? Outer inner is we multiply the outer terms and we multiply the inner terms. Okay, so multiplying the inner terms would give us -1 sine x, which is basically negative sine x. Okay, and multiplying the outer terms would give us negative, not 2. 2 times 2 is 4 sine x. Okay, and then we like sort of add them. So negative sine x, and then that gives us -5 sine x. Okay, and -5 sine x is the middle term, and we've solved for this trinomial. So taking the same approach, okay, taking the same approach to this question as we would for a regular trinomial, except considering trigonometric identities. Okay, so utilizing the variable as a trigonometric identity and then solving accordingly, right? So let's just see how we can take it slightly different. It's basically the same thing, but if this confuses you like way too much, what you could do is you could try substituting sine x with just x. Okay, so we can say, okay, we can't really say x because sine x can never be equal. Oh no, it can be equal to x, but let's just use y. Okay, so if sine x is equal to y, we can say 2y squared, 2y squared, because sine x is y, so sine squared x is y squared. Okay, let's just use x. We'll make it easier. Okay, so if we let sine x is equal to x, then again, instead of having sine squared x, we could just have x squared. 2x squared minus 5. Instead of having sine x, we could just have x plus 2 is equal to 0. Okay, so now we solve trinomially. There's no common factor we can take, but this might be a bit easier for you to understand, perhaps if that's confusing you. Okay, just if this is like exactly like how you're doing it, so this makes more sense to you. Again, now you're going to have the same thing, 2x and x minus 2 and 1. I'm not going to check it. But then basically, because you need to now draw in your trigonometric identities, remember we made x equal to sine x. So wherever you see x, you can replace it with sine x. So this becomes 2 sine x minus 1, and then sine x minus 2. Okay, is equal to 0, and you solve accordingly. So let's solve for it, right? So here we just we factorized it. So let's actually solve for it, right? So solving for it, you would equate each bracket to 0. Okay, so let's do that. You'd have 2 sine x minus 1 is equal to 0, or sine x minus 2 is equal to 0. So here you want to isolate your variable. So 2 sine x is equal to 1 if you take minus 1 over to the other side, and then divide both sides by 2, you get sine x is equal to 1 over 2. Okay, alternatively, here you could just take 2 over and you get sine x is equal to just positive 2. In that case, you have two answers. Sine x is equal to a half, or sine x is equal to 2. Okay, so take note of that. This is how you'd solve a trinomial, and then it could be general solution. Okay, but obviously we haven't learned general solution yet, so we'll solve that when the time comes. Okay, but I hope that makes sense. Trinomial identities. Okay, let's look at now a trinomial proof question. Okay, so again, these are difficult. I'm sure many of you do struggle with these, right? They get confusing. There's a lot of theories. There's a lot of theorems / identities to remember. Okay, but nevertheless, let's look at how we can approach them and let's learn some skills that are going to make solving these a bit easier. Okay, so here we have tan x plus 1 over sine x times tan x plus cos x is equal to sine x plus cos x. Okay, so how do we approach this? Number one is we generally work with the more complicated side. Okay, and we try to simplify the more complicated side. So between the left side and the right side, the left side is definitely more complicated. Okay, it has more more terms, more complex terms. When on the right hand side is just sine x plus cos x, right? There's nothing you can really simplify about this right hand side. So our objective again is to try and simplify the left hand side. Okay, try and simplify the left hand side to get it equal to the right hand side. And how are we going to do that? 1 second. Okay, and how are we going to get it to do that? By using our identities, okay, by converting to different things. Okay, so the first thing is, yes, of course, whenever you see tan x, okay, your first instinct is to always want to change tan x. So I'm going to say left hand side equals tan x. I can change to what? Tan x I can change to sine x over cos x plus 1 all over I have sine x. Please pay attention to the signs as well, not like sine x cos x, like the mathematical signs, like plus, minus, the operations. Okay, please pay careful attention to them because of course, they're important, right? When it comes to canceling fractions, you can only do that with multiplication and division. Okay, when it comes to adding fractions, you perhaps need to do lowest common denominator and so on, right? So please pay special attention to that. So here I have sine x. Now, tangent x, I can simplify again to sine x over cos x. Okay, and then I have plus cos x. But I really haven't done much, all right? Nothing complicated. I just simplified tangents to sine x over cos x. Let's simplify further. Now, before we get to the top, let's simplify our fraction at the bottom, I guess. So sine x times sine x over cos x is like having sine x over 1 times sine x over cos x. Okay, and we multiply in a straight line, so that becomes sine squared x over cos x. Okay, so I can simplify that, right? So on the top, I'm just going to for now leave this as sine x over cos x plus 1 divided by, at the bottom now I have sine squared x over cos x plus cos x. Okay, any ideas? Does anyone have any idea how we can go ahead? What should we do? Okay, what should we do going further to solve this? Any suggestions? Okay, no suggestion is a wrong suggestion. Thus is indeed the time to be wrong. Anyone? Nobody? What do you guys think? Separate it and put a division sign. Okay, you could do that. You could do that if that makes more sense. I'm going to do that in the next step. No problem. Okay. But any simplification steps? Okay. So we'll do it as a division. For those of you who prefer it as a division, it makes more sense to you as a division. We can do it like that. The bottom fraction should come to the top. Okay, like maybe like flip n times. Okay, but let's see, right? So nothing concrete yet. Cancel cos. Okay, I'm going to show you exactly why we shouldn't cancel cos. Okay, why we can't cancel cos. Thank you for that. That's important, right? So what we need to do, okay, so here's another tip. All right, by the end of this, I should have, when we've done identities completely, I should have a list for you guys of tips to follow, because these questions can be hard, right? So the first one we went through was simplify tangent. So simplify tangent to sine over cos. That's the first one, because that's one of the identities, right? The second one is when we have addition or subtraction, change 1 to sine x plus cos x. No. Okay. Okay, perfect. Thanks for that. Okay, so the first one we said was change sine, change tan, open up tan. Now the second one, the second thing we should do is, like I was saying, if we have fractions, yes, very good. If we have fractions with addition or subtraction, what do we have? If we have fractions with addition or subtraction, in this case, 1 is a fraction. Even though it's not written as a fraction, it can be written as a fraction. So too can cos be written as a fraction. The main thing is that these are our fractions. Sine x over cos x and sine squared x over cos x. Those are our fractions. Okay, so like the person suggested in chat, we need to do LCD. That is important. So that's the second thing. First one is tangent. Second one is lowest common denominator. Lowest common denominator. Okay. Whenever you have fractions with plus and minus, you generally want to do lowest common denominator. Notice I'm saying generally because it's most of the time. Like sometimes you could get a question and that's not the case. Okay. But we're talking about majority of the times, right? In those questions, you might have to like freestyle a little bit, utilize your knowledge of identities in general and your experience of solving identity questions is really important in order to allow you to able to identify what to do in a question, because there's no like set method to say do this and that each time, every time, and you're going to solve it 100% of the time. Yes, there could be a guideline to say, okay, approach with these type of questions, approach it in this way, try this and that, but it's not guaranteed to work 100% of the time, maybe most of the time. Okay, so that's why you learn it, because most of the time, if it works, then you learn that approach. Okay, so the first one is convert tan to sine over cos. The second one is if you have fractions with addition or subtraction, you need to do LCD. What is LCD? LCD is lowest common denominator. So I'm going to do LCD while simultaneously changing it to divide, if that makes more sense for you guys. So the lowest common denominator between sine x over cos x and 1. Can someone tell me what's the lowest common denominator between sine x over cos x and 1? The lowest common denominator between cos x, sine x over cos x and 1. Basically, it's between sine x over cos x and 1 over 1. That's what it's basically between, because 1 over 1 is the fraction version of that. Okay, very good. I'm trying to think, who did we do LCD with? I don't know if it was your grade or a lower grade, but yes, okay. You need to look at what's the lowest common multiple between cos and 1. It has to be cos, okay? So in that case, I'm going to write it all over cos. Okay, now remember, we need to, what we did to the denominator, we need to do to the what we did to the denominator, we need to do to the numerator. So to get from there to there, from cos to cos, from the first fraction, I multiplied by 1, right? This was the same thing. Since this has a denominator of cos, under the denominator of cos x, it will still be sine x. However, that was not the case for 1. How did I get from 1 to cos? I had to multiply by cos x. Then what I do to the bottom, I do to the top. So I multiply the top by cos x as well. And then I get plus cos x. Okay. For the person that suggested that we might need to cancel cos, and they deleted their message, I think. Okay. In that case, we could cancel cos there. Okay. And that is incorrect. We cannot do that. We cannot cancel cos across a positive like that. Okay. When we cancel, we only want to cancel division and multiplication, across division and multiplication. So if it's multiplication only or division only, yes, then we can easily cancel things, one on top and one at the bottom. Because of this plus sign, if you want to cancel anything to do with this plus sign, you're going to have to cancel this with something exact the same at the bottom. Okay, so that's in actually how we get cos x to, it's plus cos x. Then divide. Okay, how do we divide? You're just going to write whatever's here. So I'm going to do LCD as well. What's the lowest common denominator between sine squared x over cos x and cos x? Correct, right? It's cos x as well, because here it's cos x. It's the same thing as having cos x over 1. So the lowest common denominator between cos x and 1 is cos x. Remember, like, for example, what if we had the LCD between 2 and 3? We're looking for the lowest number. Excuse me. We're looking for the lowest number that 2 can, no, sorry, that 2 can go into and 3 can go into an exact amount of times, and that would be 6, right? So here between 1 and cos, between 1 and anything is that thing. Between 1 and anything is that term. So here the LCD is going to be cos x. Okay. So now this here already has cos x. So we didn't make a change to the denominator. So we don't make a change to the numerator. It stays as sine squared x. However, this term, to get from 1 to cos x, was multiplied by cos x. So we multiply the numerator by cos x as well. And we get plus cos squared x. I hope that's making sense. Okay. Thereafter, let us simplify. Okay, again, I'm going to simplify 2 steps in one. Okay, so how do we divide fractions? Okay, firstly, we can't like cancel that and that. That's number one. Again, we can only cancel top at top and bottom. Okay. Exactly. How do we divide? Just remind me, I need to come back to that person that said change 1 to sin x plus cos x. I want to explain something. Yes, we tip in times or flip in times, whichever one you've worked with. Yes, fractions. That's how we multiply. That's how we divide fractions. So this here, sin x plus cos x, I can't really simplify these. Right? There's nothing to simplify them to. Multiplied by, flip this one. Keep the first one the same and flip the second one. Sin squared x plus cos squared x. Right. Now, yes, okay, you are correct. True, thank you for that. There is a trigonometric identity, which is this. Sin squared x plus cos squared x, that simplifies to 1. Sin squared x plus cos squared x, that simplifies to 1. Okay, so I hope that makes sense. So we can simplify it there. There is another way. Remember, no, there is no other way. Sorry, this is not dots. This is the addition of 2 squares. There's no rule for that. So now when we look at this, okay, what do we see? We see multiplication. Okay, we see addition. Okay, so we can't cancel cos and cos. One, that's the first thing. We cannot cancel cos and cos because of this addition that the cos is attached to. So if you want to cancel this cos, you're going to have to calculate it with the addition and whatever it's adding to. You're going to have to cancel it. You're going to have to cancel it with this whole thing. However, there's nothing to cancel it with. However, if we look at this cos and that cos, none of them have a plus or minus before or after. They're in multiplication and division. So across from top to bottom, I can cancel cos and cos. And then thereafter, if I simplify, I'm left with sin x plus 1 over 1, which is simply sin x plus cos x. And now I have proven that the left-hand side, I can say therefore, left-hand side is equal to right-hand side. Okay. Okay, have a look at this question. I just want to go to the bathroom quickly. I'll be back shortly. But in the meantime, look, you can, I guess, review this question and see how we did it. Okay, make sure that you understand how we did it. I'll be back shortly. Okay, good people. I am back. Let us continue. Okay. Let us do this example from the Gauteng November 2022 past paper. So basically last year's past paper, right? Okay. So yes, let me discuss one thing I remembered. So yes, so again, like I said, I'm going to write it down for you guys in a list. Okay, but now let's just discuss it, right? So that you guys understand it in context with the question. Okay. So the first thing I said was for identities, right? What are we doing? When we see an identity question, we do not cry, number one. Okay, we do not leave it out and go to the next question. We attempt it. Right. Thereafter, right, the first thing we look out for, tangent. When we see tangent, we convert tangent to sine over cos. Okay. Likewise, if we do see 1 over 10, we convert that to cos over sine. Okay. That's the first thing. The second thing is if we have a fraction, okay, the addition or subtraction of fractions, basically, then we want to do LCD, lowest common denominator. When we have the addition or subtraction of fractions, we want to do LCD, lowest common denominator. Okay. The third thing, it's not really like a point of solving. It's just more so advice, which again, I'll write down this as well. Whenever you see, so someone suggested, when we attempted this question, someone suggested changing this here, this 1 to sine squared x plus cos squared x, because that's an identity, right? We can do that. Okay. Now, when it comes to sine squared, when it comes to changing 1 to sine squared x plus cos squared x, that's a very rare question. Mostly you are simplifying sine squared x plus cos squared x to 1. like in this example. Okay, that's a very rare question. And it should never be your first instinct to change from 1 to sine squared x plus cos squared x, because it's going to make your term a lot more complicated. Like imagine if we did that here, right? Instead of 1, we're going to have sine squared x plus cos squared x. Then it looks complicated. Okay, like how are we going to solve it from there? We're going to do LCD, but then if we do LCD, we're going to have 3 terms on top. Okay, so you can see how that's kind of going to make it a bit more complicated. So that's why that should be like your last resort. Just say you completely stuck and you don't know what's going on. Okay, then I'm like, okay, try converting 1, or unless it's obvious, right? Unless it's obvious, meaning like obviously you know, like what is this? This is sine squared x plus cos squared x. All right. Now, just say in your term, you have minus cos x, minus cos squared x. And you know that if you have to open up 1, this and this are going to cancel, then you can maybe try it. Okay, again, like I said, it's not like highly recommended. Like this is your first thing. As soon as you see 1, boom, sine squared x plus cos squared x. No, don't do that. It's going to make your terms complicated. Just think on it, ponder about it first, try other methods first, then maybe go back to that if those methods are not working. Okay, that differs completely to something like tangent. Whenever you see tangent, convert it to sine over cos. Okay, so yes, that's the thing about the 1. So just some advice on that. Okay, now let's look at the next one. 5.2. Given the identity sine theta minus 2 sine theta cos theta. 1 second. Let me just check if this is the grade 11 question. It's not supposed to be here. I think it is a grade 11 question. Yeah, it's a grade 11 question. Okay, so given that identity, you are required to prove the identity. 5.1.2.1, sorry, prove the identity. What is the identity? Sine theta minus 2 sine theta times cos theta over 2 cos squared theta plus cos theta minus 1 is equal to negative sine theta over cos theta plus 1. So remember the steps that we follow. We work with the more complicated side first. So what's the more complicated side first? I would definitely say that it's the left side. So we're going to try and simplify the left side and try and equate it to whatever's on the right side. 5.2.1 left-hand side is equal to sine theta minus 2 times sine theta times cos theta divided by 2 cos squared theta plus cos theta minus 1. Now, this question has 2 of the next steps that we're going to follow. Okay, but I want you guys to suggest to me, what do you think? Okay, let's work with the top first, right? So when it comes to this, we are either converting something to an identity, simplifying, or factorizing something. That's our options, right? What can we do on top? Anybody with any suggestions on what we can do on top? Okay, factorize. What type of factorizing? Specifically what? Oh, you mean like just, yeah, specifically what factorization can we do on top? Common factor. Great, very good, right? Very, very good. You need to be able to identify if there is a term in both, if there is a single term that occurs in both terms, okay, or all 3 terms, if you need to take a common factor from all 3 terms, and then take a common factor. So that's number, I think we had number 3 or 4 technically. Let's see how it pans out. But let's just say number 3, actually. We had number 3. So what's the next point? What should you try? Always, this is very important and very common as well. No, I mean, yeah, no pun intended. It's a common thing that they ask common factor. Okay, but it's common, right? So it's like your third step. You can try it, right? Try taking a common factor. See, can I take a common factor? Okay, so the purpose of making a list of things you can possibly do is also to remind you, if you memorize that list, it's to remind you the possibilities of what you can do, because sometimes you don't just you understand the trig identities maybe, and you understand, maybe not, it's not so understanding how to use it in the question, but you actually just forget about it completely. Like, okay, for example, factoring, you forget that you could have factored, but if you remember, oh, let me try to factor, then you're going to try to factor, right? And then it could work out for you. So I need to take out a common factor. What should I take out a common factor of? What should I take out a common factor of? Sine, correct. Okay, so sine appears in both terms. So I'm going to take sine theta as a common factor. I'm left with 1 here because sine theta divided by sine theta is 1. And here I'm left with 2 cos theta because that's what's left over. 1 minus 2 cos theta. Right. Then we look at the bottom. Someone tell me, any idea what can we do at the bottom? What can we do at the bottom? Any ideas, any suggestions? Okay, have a look at identities for like 1 or 2 minutes. Okay, now let's have a look at the question one more time. Factorized by trinomial, there's an identity. Okay, both of you are correct. So both of you are correct. There is an identity. Okay. However, before we convert that identity, so yes, true. Cos squared theta is an identity because cos squared theta can be changed into sine squared theta minus 1. However, before that, you need to be able to identify that you actually have a trinomial. How do we know we have a trinomial? Remember, we went through it. The trinomial, trigonometric trinomial identities, the structure of them. How are they structured, right? How will we be able to tell whether something's how will we be able to tell whether something's a trinomial opposed to like converting an identity, right? Like how you suggested, converting from cos squared theta to sine squared theta minus 1. Like, how do we know that we shouldn't do that and then we should do trinomial? Is we look out for the following, okay? We look out for a sine squared x plus or minus a sine x plus or minus a constant. A cos squared term plus or minus a cos x plus or minus a constant. A sine squared x plus or minus a sine x times cos x plus or minus a cos x. Okay, that is the format that we look out for. And as you can see in the bottom, we have a cos squared theta, a cos theta, and a constant. So in that case, we can trinomially factorize. Okay, trinomial factorized by trinomial, trinomial or trinomial factorization. All right. And that's the fourth point. Okay, so first one, convert tangent to sine over cos. If you have fractions, addition or subtraction of fractions to LCD. Third one was look out for a common factor. And the fourth one now is going to be look out for trinomials, trigonometric trinomials. In this case, I'm not sure which method you guys do prefer, but I'm just going to use the straightforward method. So the factors of 2 are definitely 2 and 1. So 2 sine theta and sine theta. Okay. Then we're going to use the factors of 1. This is easy because the factors of 1 are 1 and 1. But now the second sign is a minus, so 1 needs to be plus, 1 needs to be minus. Which one is a plus, which one is a minus? That's important for us to decide. Okay, why am I writing sign? I don't know. I should be writing cos. Negative goes in the first bracket. Let's try that. This becomes positive 2 cos x, cos theta, and the inner becomes negative sine theta, positive 2 is indeed positive 1. You are correct. Okay. Negative goes in the first bracket. Okay. So in this case, okay. So right now, okay, when we take these steps in proving identities, a lot of the times our objective is to actually simplify by canceling. Sorry, there's something wrong with me. Genuinely. Thank you for that. Yeah, it's supposed to be cos, not sine. I'm just writing sine completely for no reason. Okay. So yes, when we simplify these identities, many times we simplify with the objective of canceling. Okay, we simplify with the objective of canceling, like when we take a common factor, or when we do trinomial factorization, we end up canceling what's on top and what's at the bottom. And that's a hint, like you should know, expect the question, something to cancel. If something's not canceling, feel a bit weird, like why is something not canceling? Like I need to solve it. I need to take common factors. I need to do trinomial so that I can cancel it. It needs to simplify. Generally, that's what happens. Okay. So in this case, so my objective of telling you that is to get you to have that mindset of looking out for the canceling. Okay. And yeah, just always looking out for it. So when you look at this question, you'll notice that we have this bracket. Okay, we have 1 minus 2 cos theta. Then we have 2 cos theta minus 1. So again, like I said, you are constantly looking to cancel. Okay, but now you want to cancel this, but why can't you cancel it? Because they're not exactly the same. The first one is 1 minus 2 cos theta. The second one is 2 cos theta minus 1. So in that case, what you can actually do is take a negative bracket of one of them. So I'm going to take the negative bracket of the top one. Okay, and actually I'm taking the top one because I can see that there's a negative in the top one, but let's just say if we took it from the bottom. So let's just say sine theta 1 minus 2 cos theta negative. So remember, when you multiply it by a negative, okay, you have to flip all the signs. So then it becomes positive 1, negative 2. So positive 1, negative 2 can be written as 1 minus 2 cos theta times cos theta plus 1. Okay. And now, okay, so just by the way, you might be asking, like, why did this guy just randomly multiply by a negative? Okay. I didn't change the value at all because when I multiply this bracket out, I'm going to get back to that. Because it's going to be negative 1 and positive 2. So when you take out the negative bracket, it's not changing the value. Okay. You take out the negative bracket just so that you can cancel. Okay. And then you left with a negative 1. So it does have its effect. Those two can now cancel. So you might be also asking the question, but you said you can't cancel across negatives and positives. You can't cancel across adding and subtracting. Okay. You can only cancel in multiplication or division. However, here we have multiplication. So sine theta times that bracket, and then this bracket times that bracket. So there's multiplication. So provided I cancel, when I'm canceling, I cancel the entire bracket with the term before the minus, the term after the minus, or the term before the plus, after the plus. And the same thing goes for here. I cancel it and I move on. So now I can simplify. This is equal to sine theta divided by, I'm left with -1 at the bottom, cos, open this bracket, cos theta plus 1. Now, before I'm very close to the answer, and you should also pay careful attention, right? So this, again, these are like key advices that I'm giving you as we go along to solve this question, which is important, right? Because it's like, sometimes you're a bit confused, right? So what's also important is, so maybe even in the start, or maybe even towards the end, but it could be influential to you, it could be beneficial to you to look at what you're trying to get, to look at your answer like, oh, I'm trying to get negative sine theta, cos theta plus 1. And then you might be able to see in your question a direction that's going to head you towards this. Like, for example, here, instead of multiplying out this negative, I know that the question is took it to the top. So I'm also going to just take it to the top. Negative sine theta, cos theta plus 1. And therefore, now I've proved that the left-hand side is equal to the right-hand side. Okay, so yes, in that case, those would cancel. Yeah, so by the way, you can do that. Like if the negative is at the bottom and at the top, it has the same value. The negative could be like, for example, negative a over b is the same thing as having a over negative b, which is the same thing as having negative a over b. They're all the same thing. Okay, cool. So let's end it there. Next week, when we come back, we'll do this weird example. You can alternatively, you can try it on your own, and then we'll come and we'll do general solution. Some trinomials there as well. Fun stuff. Okay. So yeah, I'll see you guys next week. Thank you guys so much for joining. Sorry, I was a bit bubble-ass today. I fell off to sleep on you guys for a second there, but we finished. We managed. We got through. I will see you guys next week. Good luck. I think you guys are on a holiday again, so enjoy your holiday. If you're not, don't enjoy it, I guess. I don't know. But yeah, do you guys have any questions? If there's any questions, I'll answer it in a few more minutes. If not, then we can end. Okay, doesn't seem like there's any questions. Yeah, for those of you who maybe have asked me a question via WhatsApp, I will get to replying to them hopefully within sometime on this weekend. But yeah, thank you guys so much for joining. Again, I wish you guys have a good holiday, and I will see you guys. Please give me 6.4. When you say give you 6.4, you mean you want the memo? You want the memorandum. Daar is die memorandum. Na die einde van die PDF. No, just the sum. Okay. The PDF will be uploaded as well, so you will have access to it as well. Okay. And the memo is at the end. Okay, I guess you should have it down. So let's end it there. Perfect. Thank you guys so much for joining again for the millionth time. Have a good holiday. I will see you guys next week. Jazakallah khair.